Okay, so it's been a week. I guess doing a long 3 hour stream was. Let me get my webcam sorted out. Okay. I'm still blocking most of my face with the mic, but I think that's not much to be done about that. Yeah, so it's been a week since my last stream. It's been a busy week. I ended up going to a conference called Embo++, which is a C++ conference. We were cross-promoting Oxidize conference with Embo. I had a chance to speak for I gave a quick 15-minute lightning talk about what embedded Rust was there, and had a lot of interested C++ developers. So if you were there and you met me and you are watching the stream now because you met me there, welcome. But yeah, it was great to meet a lot of people and see the interesting things that are going on in C++ embedded world, as well as the thing get to talk a little bit about what's going on in Rust. So last week we got basically the wireless communication between two nodes going, and going decently well. We had some basic kind of hello world messages where we were just sending random chunks of text back and forth. We had some timers going. We had message serialization, sending packets back and forth. And then I put up a poll that was asking what I should do this week, and people wanted to see more message protocol work. So I had to go out and think what I actually wanted my wireless sensor nodes to do. And I remembered an old project idea I had before I actually even started with Rust. So as background, I am an absolutely terrible sleeper. I have I'm bad at going to sleep, and then once I'm asleep, I'm bad at waking up. So a while ago, I had an idea for an alarm clock where I could have something next to my bed with a screen and a big old speaker on it that could be the alarm part of the alarm clock, where it would show me what time it is and let me set maybe what time I wanted to wake up, or something like that. Sorry, I've got stuff in my pocket. So I would sit next to my bed like an alarm clock, and I could set time, and then when the alarm would go off, it would go off, and hopefully that would wake me up, and it'd be very loud. But instead of just being able to hit snooze, like I do with every other alarm clock that I've ever owned, the idea would be that wirelessly, I'd actually have the off button in another room. So go put it in my bathroom or something like that, so I can't turn my alarm off until I'm actually in the bathroom and ready to take a shower. Let me move this a little bit away from my face. So that was kind of the idea, would be that I had to get out of bed, and my hope would be that by the time that I was actually out of bed and I had gone into the bathroom to take a shower, that I would decide that was just enough and I would actually wake up and stay awake. Ended up not doing that project. I was originally going to be doing it on a TI Launchpad with some Zigbee radio, or some XB, like the Adafruit XB radios. I had that up and working a little bit. Never ended up getting the parts for the alarm clock. But I figured, now that I'm going to be building a wireless sensor node network, now it might be time to look at that again. And an alarm clock is nice because it's pretty simple in that it needs to do a couple really basic things, like keep track of time and have a buzzer, and probably have some kind of screen so that I can see what time it is. Although I guess that's optional. I guess I just really need it to make noises when it needs to make noises. But I thought that'd be a good first thing, or at least a thing that I could do, and it would give me something to think about when I was starting to put together my message protocol for this. So what I'll probably end up doing today is I'm probably gonna write down some requirements. I'm definitely keeping my engineer hat on, and before I start coding, I probably want to start at least sketch out initially what I want to do for an alarm clock, where that can I guess be the first smart device in my house, unless you count like a Chromecast or something like that. But I don't, for being someone who's worked on IoT devices, I surprisingly have, I think, 0 IoT devices in my house, except for the normal culprits, like my TV's smart, but I don't let it connect to the internet. I guess I have a Chromecast. I guess that's an IoT device. But other than that, I don't have like smart light switches or anything like that. Yeah. But I guess this would be the first smart device I'd have in my house. Would be a smart alarm clock that I could maybe configure remotely, and maybe even give it a battery backup. So if I get angry and I unplug it, that doesn't stop it from working, or if I want to take it on the road with me because I travel for work decently often, that I could take that with me. And I'd probably need a little base station for my laptop so I could reconfigure it if I needed to, or maybe eventually I'll get Bluetooth going on this board. Yeah, so there's a lot of options there, but I think we could get something basic working hopefully relatively quickly, and gives us a target to develop against. So I guess I'll start taking some notes about oh, and the other thing that I said I was going to do is I was going to clean up the work from last time, because if I start having multiple different kinds of nodes, I'm going to end up wanting to share code between those different nodes, but I'm going to end up having a couple applications. So I'll probably end up thinking about how I can refactor my current code, which is just one like binary application, and start splitting it off into a couple of libraries where I can have reusable libraries where if, a bunch of these need a speaker, if I want to put a buzzer next to my door for an alarm clock, and I want to have a buzzer next to my bed for an alarm clock, and a buzzer next to my door for a doorbell, I don't have to copy and paste that code between different repositories. I also, at Embo, Hano, who wrote the DWM 1001 crate, was there, so I had a chance to talk to him a little bit. So I've submitted my PR. I ended up submitting a PR to the DWM 1001 repo where I provided smaller constructors for individual parts in the repo, so that when I'm using RTFM, and since I can't use the whole board support crate as it currently exists, that I'd still be able to use the building blocks in there. So hopefully that code eventually will leave this repo and go live upstream in the DWM 1001. So I submitted that. Hopefully that'll get merged. I know Hano's really busy right now, so hopefully that will get merged sooner than later. But I guess before I get started, let me do my plugs first. So yeah, if you're interested in embedded Rust, definitely come check out Oxidize Conference. This is the website. It's Oxidize. Let me unfull screen this. It's oxidizeconf.com. We'll be doing, at the end of April in Berlin, Germany, we're going to be having a 4-day conference. The 26th, which is a Friday, is going to be full-day workshops where we have kind of a beginner, intermediate, and advanced embedded Rust training course. So that's a full-day hands-on training using the same hardware that I'm using here for my stream. So if the stream is interesting and you want to learn a little bit more, the workshops would be a good place to do that. The Saturday is going to be a full-day conference, so we're going to have a bunch of different talks, and we've started announcing those on Twitter. So we've announced some ones like people working on RISC-V and some newer versions of the ARM architecture and integrating Rust with existing RTOSs like RiotOS, people who are building Bluetooth skateboards in embedded Rust. So if you want to see people using Rust in production and talking about the challenges and the successes they've had with that, definitely come check out Oxidize. You can buy tickets on our website, and on Twitter there's actually a promo code, that speaker flash sale, for 20% off. That promo code's good until Tuesday. Today's Sunday the 17th, so that promo code is good until Tuesday the 19th, until like 9 p.m. Central European time on Tuesday the 19th, so you can get 20% off any of that. And yeah, and a reminder, this stream is brought to you by my company Ferris Systems. So if you want even more help for your own kind of projects, we do consulting stuff in Rust. So I guess I'll leave that to be all of the plugs for today, and I'll get started on the actual fun stuff, the streaming and the development stuff. Oh, and one last plug. If you want to chat with me during the stream, we're on the Rust embedded. I think it's burned in over roughly here. But yeah, Rust embedded on ircmozilla.org. And let me tab over to that. Yeah. Oh, there's already some people talking in the chat. So if you are interested in chatting with me during the stream, chat there and I will see your message. I know there's a bit of a delay on the stream, but once I see your message, I will answer your questions. And if you have questions, I'm happy to chat about it. I can move the IRC window over on screen if I need to, but yeah. So welcome to everyone who's on IRC, and let's get started. So my first, let's see, I've got notes. I probably should just get rid of notes and make like a note repository, but let's, for now, let's just make a alarm clock.md. So I'll have my notes on making an alarm clock So I should probably think about like, what do I need for this? Let's see. Well, an alarm clock's going to need to be able to keep time. So I know that the NRF52 has a built-in NRF52 RTC. So it's got a real-time clock, which, so normally on the processor, if you see like in the delay module that we've used before, this is just using, it's counting clock cycles really, so that there's a timer peripheral on the chip that you say, okay, cool, you're going to count 50,000 clock cycles, and you kind of figure out, okay, the clock's at 64 megahertz, so if I want it to wait 10 milliseconds, then that's going to be, 64 million per second divided by 10 millisecond, which is 1/100th of a second, and you kind of figure out how many clock cycles it's going to take. And that works pretty well, especially in like a short amount of time. Like if you're just measuring it once, then that's going to be pretty accurate, because the clocks on these processors are pretty accurate, but the problem is they can kind of vary wildly, and usually it's based on temperature, and they're also not calibrated. So you're going to be aiming for 10 milliseconds, and you'll probably be something like 9.995 milliseconds or 10.005 milliseconds, and that works really well. Like as a human, you won't even notice that. But if you're counting kind of over and over and over like a clock, like I'm counting every second, and over time your clock drifts, then you're going to end up losing seconds. And if you're something like 98 or 99% accurate, that means you're losing 1% of your seconds in a day, or gaining 1% of your seconds in a day. And some of these clocks can even be worse than a couple percents. They can be like 5% accurate, which the microcontroller won't notice. It's still happy to run like a CPU, but if you're trying to keep like accurate clock wall time, the errors add up over time. So if you let it go for a week or a month, you can lose seconds and then eventually minutes, and then if you go long enough, then you'll lose maybe hours over a year, or a couple hours over a year, which isn't great for an alarm clock, because that's annoying. So what these microcontrollers typically have, either on board on the microcontroller or off board of the microcontroller, is they have what's called a real-time clock, which is not based on the high-frequency clock of the microcontroller, so like 64 megahertz, but they're typically based on a clock that's a low-frequency clock. So these are typically 32.768 kilohertz, which is going to sound kind of like a familiar number if you've done binary before, because they actually resonate at a frequency that's super easy to step down to seconds. Because if your clock resonates at 32,768,000 times a second, then you just have to divide that by 32,768, which is a binary multiple, and then you get a really convenient 1 second or even 1 millisecond tick out of that. So there are definitely different layers of accuracy you can go here, and I haven't looked at the data sheet for the NRF52 to figure out how accurate it is, but they're typically more accurate than the high frequency like 64 megahertz clocks. So we're already going to be a little bit better than that. They definitely make some ones that are controlled, like you'll have what are called temperature controlled oscillators, or TCXOs. And those are really nice because they're calibrated over a wide range of temperatures to be really accurate. Like, they're usually measured in parts per million. So you would have a clock like that's rated to 10 parts per million, which means for every million ticks, you're never going to lose or gain more than 10 of them, which means that you have a really high accuracy there. And that's great if you're trying to do like high precision timing. Like I need something to start and then measure exactly 8,000 seconds and then go off exactly 8,000 seconds later. We don't need that kind of accuracy. We just need, like, for an alarm clock, we need like plus or minus a minute or two. And these devices are going to be connected, which means periodically, like once a day or even once an hour, they can kind of ping back to a computer that's connected to the internet that has a something like what's the web time? There's a protocol on the internet where you can basically connect back to like the atomic clocks that are keeping hyper accurate time and always like do fine corrections on your clock. So what we're probably going to spec out in our protocol, so it needs to keep time, which means it needs a real-time clock so that we're at least, ballpark accurate here, something a little more accurate than our high-frequency clock, we need to check back for fine tuning. So we'll probably need some kind of message protocol for setting getting time. So our web server maybe once an hour can send out a message that says, hey, we are exactly the time right now is 5:11:05 p.m. So it can send back 5:11:05 p.m. Maybe periodically send that out, or when the device first boots up, if it doesn't know what time it is, it can say, hey, what time is it? And it can ask for the current time and get some kind of current time so that it's not sitting with an inaccurate time, or just like your oven when it powers on, it's blinking 12 o'clock or something like that. So we'll probably need some kind of message protocol for that. We probably need some kind of way of setting an alarm, where we need an ability to remotely set an alarm. Maybe I'll have some kind of button-based UI here eventually, but for now we're probably just going to require our computer, like our server or something, to send and what time the alarm is supposed to be. So we probably need to remotely set an alarm and probably remotely get set alarms. I should probably say alarms, because I'm probably gonna, until I have that thing where I can turn it off in another room, I'm probably gonna do what I do with my cell phone and set an alarm for every 15 minutes and make sure that eventually I get out of bed. So that's kind of our alarm. I guess for our alarm, we're also gonna need the ability to drive some kind of alarm. So that might be like a piezo buzzer, which is like a little buzzer where you kind of PWM or pulse stuff at a certain frequency into it, and it amplifies that and buzzes for you. This is probably if you have an alarm clock and it just makes a really basic annoying beep. It's probably using a piezo buzzer. So maybe that. I might want something. I posted on Twitter asking people what I should do for this, and they gave me some really interesting options, like a car horn. I don't know if I'm gonna go that big, because I'd like my neighbors to still like me, and I'd like my dog not to freak out. So maybe something bigger. But maybe I can get smart where the first alarm goes off, and if I haven't gotten out of bed after 20 minutes, then the bullhorn goes off. So maybe that would be like driving a relay or something like that. We'll figure that out. This is a moving target, so we can figure out what's going on here. Maybe in the future we'll want some kind of screen. We could probably use the ubiquitous 16 by 12 character display that everyone uses. 16 by 2 character display. I know I actually have one of those sitting in a box somewhere. I have one of them that I think is broken. I think it got crushed in a move at some point, but I think I bought another one that has an I2C driver chip on it, so it's got that. So most of those are based on the HD 44870, something like that. It's not really a protocol, it's just someone made a chip a long time ago that was super widely used, and then everyone cloned it, and now it's become sort of like a soft standard of driving a parallel 16 by 2 character display. But now you can buy all the cheap clones of it, and they make like a 16 by 4. So I'm gonna want to have some kind of character display. I know I have seen Rust drivers for both of these before. So yeah, for my driving my alarm, I'm probably going to want to use PWM for that, because the hardware has built-in support. So PWM is kind of a way of pulsing a signal automatically, where instead of, if you've used Arduinos and you've used analog write, that's PWM. And what that does is you say, I want my signal to be on for 50% of the time. So that means I'm going to set up what my frequency is, and then at like 400 kilohertz or something like that, it's going to say, okay, I'm halfway through this pulse, so now I turn it on, and then it goes a little longer and it turns it off. And you end up having kind of an analog signal that's driven by a digital signal, because it goes kind of like low for a little bit, and then it's high for, it goes high for a little bit. This is not a good diagram. I should not do diagrams in ASCII, and then it goes low for a little bit, and then it goes high for a little bit. And if you have a signal that looks like this, where it's on half the time and off half the time, this is your analog write of 50%. And normally if you have something like an LED, if that's blinking fast enough where the human can't see the difference, then that just looks analog to you because the LED is being pulsed at a high frequency. If it's something like a speaker, it's going to sound like, 50% as loud because you're putting 50% of the energy in there. If you really need it to be analog, you can put this out to like a capacitor circuit or something like that. Yeah, so the Real Prof just posted the HD44870 does have a driver. I know I've seen that, and I think I've even seen some like higher level abstractions where they're not even tied to that one. But yeah, I definitely plan to use the HD44780, 780. He made the same swap. It's one of those, like, I think the HD is like Hitachi displays or something like that. I don't know if Hitachi still makes displays, but this is still a kind of standard. So I might buy one of those. The whole point of this stream is to do it as quickly and easily as possible. So if there are kit parts that I can buy, I will probably I will buy the overly expensive one and use the overly expensive one. When I say overly expensive, it's like, oh, I'm buying a €20 kit part instead of going on DigiKey and sourcing my own controller. And yeah, he's pointing out that, yeah, normally there's two ways of driving this. You either you drive it parallel, because the display itself is parallel, which means it takes like 8 or 12 or 16 pins to really drive this display. But the thing is, the display doesn't have to be driven super fast. So what most people do is they put like an I2C or an I2C port expander on it, where they just send these commands very slowly over I2C. And I say slowly, like 400 kilohertz, which is really not that slow. But if you really only need to update the display 5 times a second or something like that, these port expanders let you control it with 2 pins instead of 12 or 16 pins. And we have a good number of pins here, but probably like the NRF 832 only has 32 pins to start with, and I know some of them are pinned out to the radio and the accelerometer that's on there, so we don't have a ton of extra pins to work with. So we'll probably end up using one of those I2C port expanders as well here. The Real Prof is also suggesting an SSD 1306 LED. That's also an option. I know those are a little bit smaller. I do wear glasses. I'm not super blind when I get out of bed. I can read. I have astigmatism, so I can read, but I have to focus a little hard, and it's a little harder when I first wake up in the morning. So I don't know how big those let's pull up what we're talking about here. So HD 44780, because you out there on the internet will recognize what I'm talking about. So so let's pull this up. So like something like this is what I'm talking about. So if you've probably even seen like pieces of hardware that you buy that have a little screen that looks like this, and you didn't even know that it looked like this. You just see like a little cutout. I've seen like coffee machines that have these. I've seen like motor controllers and stuff that have them because they're super ubiquitous. There's drivers for them. There's hardware for them. And they're 16 by 2 displays because they got 16 characters horizontally and 2 rows here. As you see there's bigger ones that have, this is a 40 by 4. Usually the most common ones are either the 16 by 2 or the 16 by 4. I know Adafruit makes a module that you can just buy. So like they sell a kit like this that has some buttons and stuff on it. This is really tailor made for making an alarm clock or something like that. The other one that the Real Prof mentioned was SSD 1306. I've seen this all over the place, and I know there's also a Rust driver for this, where that's an LCD display. This is an OLED display, so you, instead of having just like characters, it's got pixels essentially that you are working with. The problem with this is I think the 1306 on this it's 1.3 inches by 0.6 inches or something like that. It's not very big. It's pretty small. It would work as like a little, if I wanted something very portable, I could use that. I might be wrong with that size thing. I don't know where the 1306 model number comes from. They have them, but they're not super big. Like this one is 128 by 32 pixels, so you can do that same kind of, character display on there. They have ones that are bigger and smaller, so it's definitely not the size. I guess it's probably the controller that's used to control this OLED screen. But I guess if I did something big like this would be okay. But this is about the size of like a watch face. So we'll see. Maybe I'll peek around for screens. I probably won't, to be honest, initially I probably won't put a screen in there, and I probably won't even put an alarm in there. Probably the first couple days of working on this, I'm going to be using an LED to simulate my alarm, so I'll use PWM on an LED pin, so the brighter it is, the more that I know that it's actually working. So that's going to simulate there. I know someone on Twitter pointed out that something like between 1 and 3 kilohertz is kind of where your ear is most positively tuned to. So we'll probably choose a couple of alarm tones in the 1 to 3 kilohertz frequency. Maybe we might even write a little song here just to, once I have an actual speaker there to set it up. I know the JPster, so or Jonathan Pallant, he has a project called the Monotron, which is, let me pull that up. JPster, Monotron. He actually has a really good, he has a really good talk at Rustfest, and I think a couple other places, where he's talking about, he's got this retro computer where he uses it's a Neo retro computer where he's using an ARM Cortex-M to simulate like an old like Z80 or Commodore 64 style computer. I can't remember exactly what he's inspired by, but he's got this standalone little PCB where, he's got all that going on a computer, and he's kind of building his own operating system as a platform that he's working on for that. But he's got a little piezo buzzer here, and he can play like, chip tunes and things like that on there, which is really cool. So I might bug him and see what he did, or I say bug him, but he's got it on YouTube and stuff like that. So I'll check that out because, why reinvent the wheel? So let's say setting an alarm. Maybe I'll have I'll throw this in there optimistically, polyphonic tones. So what I mean by polyphonic is if you have like just monophonic, you are setting like the frequency over time. So you could sing a song, but you can only do one note or frequency at any given time. And this is it's okay for an alarm clock, because I might just beep at some frequency, and that would work. But if I want to sing myself a song in the morning, maybe I can make it so I can sing myself a song where it's playing multiple tones at the same time. Maybe if I feel like getting fancy. But really, we need to be able to keep time, so that's going to be a thing. We're going to need to set an alarm, so I'm going to need PWM. I can tell you right now, the RTC is not implemented on the NRF52 board support crate, so I'm going to need to implement that. Let me pull up. I don't know if in the NRF52 if we have PWM implemented either. So let's go look at the PWM. I don't see PWM. So likely we're going to need to driving some kind of, we're going to need to implement not implemented. So now I am signing myself up for implementing stuff in the driver, but that's good because the driver could use that, because PWM is super commonly used, and the real-time clock is super widely used. And one of the things I said I was gonna work on was some kind of system timer. And if I only need like low resolution, like not wake up in 10 microseconds, but wake up in 10 milliseconds, or wake up in 10 seconds, or wake up in 10 minutes, then I don't really need a high frequency clock on that. It'd be nice to be able to set myself an instant that was like, wake up in 10 minutes. Eventually, let's put some more stuff on there. I'm going to throw this as an aggressive goal in there, but low power mode. So I would need, if I want this to be an alarm clock that's powered by a battery, and I want that battery to last more than like a day, even with a pretty good lithium ion battery on there, I'm going to need some way of putting myself to low power mode. So that's going to need something like the power states. The Real Prof made a good point that the NR51 code does have PWM stuff in there. So Because the NRF51 hardware and the NRF52 hardware are so similar, I'm probably going to be able to go steal some code. And we've done that before on a couple drivers where we've kind of cross-ported the driver from the NRF51 HAL. So the NRF-RS repo, we support both the NRF51 and the NRF52. So let's go see what the NRF51 HAL has. I don't see PWM, but the real prof was pointing out that there's the microbit crates. And the microbit is a cool board that's used for teaching, and he's saying that they have PWM code. El Suizo in IRC is asking me, why not an MP3 player? An MP3 player is really difficult. So it's certainly an option that I could do. But we've got... Okay, so there's kind of two ways to implement an NRF52, an MP3 player. You can either implement it on the microcontroller itself, where you manage everything in software, where you do your MP3 decoding and playing music and stuff like that. But that means I need to have a lot of things. I need to have some kind of flash storage, like an SD card. So I need an SD card on there, because this only has 512K of flash, which means I could put 30 seconds, 15 seconds of song on there and play it over and over again. But what's more likely is I would have an SD card in there. So I would need an SD card driver. And I know for his Monotron, Jonathan has built an SD card driver and a FAT file system on there. So I could steal that, but I'd have to at least port it to the NRF52. So that's my storage of media. I would need to be able to play my media. And the NRF52 does, I think, have a... Does it have a DAC? So DAC is a digital to analog converter. So this is kind of the really hi-fi version of PWM, where you have like a digital input signal and you turn it into an analog output signal. I don't think the NRF52 has a DAC built in. Quadrature decoder. Okay, it does. It has a successive approximation analog to digital converter. There's a bunch of different kinds of analog to digital converters where they're good at different things, whether it's like speed. I mean, for audio, you need something like 44.1 kilohertz output. I don't know if this SA-ADC is good enough to do 44.1 kilohertz audio output. It's only got 12-bit resolution, so it might be able to do it. The other thing, which El Suizo has just pointed out, is the other option is you use an external chip. So you use an external chip that handles all of the decoding and things like that. So I still need my SD card decoder, or maybe I even there's some totally integrated MP3 player chips that do the decoding themselves. So you just plug an SD card into it and you plug an audio source into it and you do that. Let me pull up the link that El Suizo has posted. Where's my mouse? There's my mouse. Posted in Amazon links. This looks like a DIY kit. Yeah, so this is something like where they have like an all-in-one chip that you can put the SD card in there and you can play it. ADC, DAC, MEEK. Was I mixing? Oh, is that a significant ADC? Is that not a DAC? Oh, you're right. This is an SA-ADC. It's not an SA-DAC. Yeah, so there's two things. There's the DAC and the ADC. ADC is analog to digital, which is that's digital read, which is, you measure an analog signal and you get back a digital approximation of that analog signal. And then there's the other way, DAC, which is digital to analog, which is you take a digital signal and you turn it into an analog signal. Like I said, that's kind of what PWM does, but at a much higher fidelity usually. So TLDR, we're definitely not going to do the manual version because, for this stream, I'm probably going to do a bunch more like wireless sensor node stuff. So sensors and actuators and stuff like that. Less handheld devices. Nothing fully implemented HAL traits just yet. The other option where I use just like a totally integrated chip, that I might do that. That could be an option. Probably won't do that first because I have Bluetooth headphones. Well, maybe if I get Bluetooth going on this, that would be really fancy. But then I'd have to do audio. the thing is with Bluetooth audio is not using BLE, and I don't know if the NRF52 can do the kind of Bluetooth where you can do audio streaming on there. So the answer is it's complicated, and for this stream I aim for not complicated. So if I was making a product, yes, you could do that. For this stream, probably will not do that. The real prof is also pointing out that we're working on some PWM HAL traits. So for embedded HAL, some kind of generic portable code for PWM. So this is the microbit. Add non-blocking LED display driver. So I guess this is for PWM. So I might look at this code. So if I start looking at PWM, this is probably what I'm going to look at, because the real prof is very smart, and if he has implemented it already, I'm not going to go and reinvent the wheel. I'm going to make this as shared code between the two repos, at least as much as I can, even if it's shared copy-paste code. And other people are saying that there are other things that are possible. So my answer is you're not going to see an MP3 player real soon, but I could put it on the backlog, but it's probably not going to be in the first 4 or 5 things that I build. Okay. So, yeah, there's that. So I'm getting lost in the weeds now. We haven't even started coding, and I've been streaming for half an hour, and I'm just talking. But I guess you watch the stream to watch me talk, because otherwise you would just look at my Git repo. So, some stuff. So yeah, TLDR, probably what I'm going to do for the next couple streams is I'm probably going to, this stream I'm going to start cleaning up the code. The next thing that I'm probably going to do is either look at PWM or I'm going to look at the RTC, whatever I feel like. And I'm going to start implementing one of those. I don't think the NRF51 has implemented the RTC either. Someone in the stream who knows much better, like the real prof who works on the NRF51, if you have implemented the RTC, let me know, and I will probably go steal that code. Otherwise, I don't think the, famous last words, I don't think the code for that's super complex, so I'll end up probably implementing a driver just in my binary project, getting it to a point where it works, and then basically yanking that out and opening that up as a PR to the NRF52. So I'll probably do that. That shouldn't be, if it gets really complicated, I'll end up like vendoring the NRF52 and opening up a PR based on that. But yeah, probably one of those options. I'm feeling like implementing an RTC, so that's probably what's going to happen first. Yeah, cool. So let's look at the code. It's been a week since I looked at this code, so let's figure out where we're at. So we're still on the master branch, which is good. I've got my hardware. Let's get that plugged in. Okay, I've got that actually plugged into USB. So let's get my JLink GDB server up and going. So now I'm connected to that. Let's save this. This is my ASCII art, beautiful diagram. What do I need to do? Okay, so right now I don't have a Cargo Workspace or anything set up. I just have like one Cargo repo where I have all of this going on. So let me look at this. What do I have that's reusable? So the logger stuff is definitely something that's going to carry over multiple one of these, because when I improve my logger once, I want it to improve for all of my sensor nodes. I have some stuff in here. Like I've got my messages and stuff like this. This is a throwaway message, so this probably isn't there, but I'll probably end up having like a protocol repo that's just like a library crate that defines all of my messages for all of my devices and how to serialize and deserialize that. I'm hoping, we'll see at the code size, but I'm hoping that the code is smart enough where if I have 100 different messages and each device can only process 5 of those 100 messages, that it'll throw away the decoding and encoding code for the ones that I don't use. If that's not the case, then we'll come up with a somewhat smarter solution, or I'll end up breaking the protocol into a couple parts, and then the server will be able to decode kind of the master protocol, which includes all the messages, and then all the other ones will just include the ones that they do know about. But that would be a little more complicated. Yeah. So what do I have so there's definitely like these initialization parts in here. I can do that because most mostly I'm going to be using that. Actually, you know what I may end up doing? I may end up just switching to my fork of the repo, because I don't really want to duplicate that code that I did there. So what I'll probably end up doing is I'll probably end up switching to my fork of that. So let me make my, let's just make a what's today's date? I'm gonna make a 2019-03-17.md. You know what? Let's refactor my notes real quick. Let's just make dir notes. Let's close all these. Close other tabs. Let's move notes.md. Let's call this misc to notes.misc.md because these are old. Move alarm clock into notes. Move to notes. Okay, so now I've just got my notes in there. So I'm just gonna keep all my notes in there because otherwise I'm just gonna throw them away or keep writing over them. And markdown files are pretty easy to keep around. So let's go into here. What am I gonna do today? To do. Probably not a lot because I'm already an hour into the stream, and I'm not gonna do another 3-hour stream today. That was, you could tell if you watched to the end of that last stream. By the end of it, I was just making dumb mistakes, and that whole 20 minutes I spent fighting with Serday was dumb. And if I had had a fresh brain, I probably wouldn't have needed to do that. So what am I gonna do? I'm gonna switch to my fork of to DWM 1001 that has the kind of the cleaner setup methods in there. And if Hano doesn't take that, then I'll just end up copying and pasting that code into my repo, and haha, it's my code now anyway. I'm gonna make 2 projects. I'm gonna make a base station. So this is gonna be the code that actually lives on the device that's connected to my server or my laptop as just a or let's use consistent industry terms. This is my gateway router. It's really my gateway router modem. So typically what you have is in IoT systems, some IoT systems use common protocols like Wi-Fi, but the problem with Wi-Fi is Wi-Fi is not a super low power friendly protocol. So typically you have a way less common protocol used, and you'll use something like 6LoWPAN, you'll use maybe Bluetooth mesh, maybe Zigbee or something like that. But the problem is most computer systems don't have those radios built in. So you either have you don't just have a Wi-Fi router that you can buy that's this is my Zigbee router. At least not commercial. There are a couple, but they're not as widespread as Wi-Fi. So what you typically have is you have what's called a gateway router. Where this on one end will have Wi-Fi or Ethernet so that it connects up to the internet. So on one interface it has the internet, so it's providing connectivity upstream, and on the other side it will have kind of the domain specific radio, where this could be, like I said, Zigbee. It could be something like 6LoWPAN. It could be Bluetooth mesh. Bluetooth mesh, where that kind of provides the bridge from these low power devices that might even be able to speak. If you're using 6LoWPAN, they can speak IP protocol, but they can't speak Wi-Fi and they can't speak Ethernet, so they don't have their own connection to the internet. But this acts kind of like a wireless router for these devices. So you have, what we're gonna have this, we're just gonna say 802.15.4, and my protocol right now is just gonna be the Internet of Streams wireless protocol, which is a bad idea before it even starts. Until basically we get 6LoWPAN going, it's gonna be I should just call this what it is. It's proprietary. And a ton of manufacturers do this. They just don't use standards. They just use like, haha, I have my package protocol and I'm just going to use that, or whatever works for the product that I'm shipping. So let's not even call it my protocol. Let's just call it proprietary, which is what we're going to be doing for right now because it's not interoperable with anything else. Mine's an open source proprietary protocol, but yeah. So we're going to have that where this connects to my base station, which is usually an embedded Linux system most of the time, just because it's, easier to deploy. That way you can run embedded Linux on the base station. You can remote into it remotely with SSH or whatever management protocol you're using, and then you connect all of your devices. And sometimes you'll even have like a bunch of gateway routers if you're covering an entire building or an entire area. Yeah, these are kind of the definitions of like a wide area personal area network. This would be like a personal area network is like Bluetooth, where it's just on you. There's a couple different definitions that are used super inconsistently, but there's kind of three levels of these networks. You have like PANs, which are like stuff that are talking on like the size of a body, so let's say like 5 meters or something like that around you, 10 meters, 20 meters. And specifically WPANs are the wireless versions of that. There's WANs and things like that, and someone's going to correct me in the comments, but these are for like the next size up, like a house or a warehouse or something like that. And then there's the much larger ones, and my name is stuff like someone will correct me on the terms, but stuff like LoRa is one of these, or a cell network like NB IoT, where you have a protocol that covers like a cell phone tower. So this would be something like 5 to 50 meters. A WAN might be something like 300 meters to a kilometer, where it's like a base station. And then you have these ones which might be something like tens to hundreds of kilometers. We're going to be aiming for like somewhere in this neighborhood of device. But I've gone off the rails now. So I need my gateway router modem. So this is just misgrants. Cool. So that's down there. And we're gonna make our first. We'll probably have like we're gonna make a Scratch sensor node, because when we're just hacking on something, we'll probably just do it in our Scratch sensor node and keep that alive, and it's gonna be hacked on and stuff's gonna be ripped out and put in, and it might just end up being a template kind of thing, but we'll work on that. And we're gonna have our alarm clock. So now 3 of an increasing duo of projects. Make projects. We're gonna do that. If we have time left over, we're gonna start looking at either PWM or RTC. One of these two. And we're definitely getting closer to an hour in, so let's get a move on, because let's spend at least an hour coding. Hour talking about me ranting about IoT and projects and things like that. Okay, cool. So let's start by switching to my fork of the DBOM 1001. So let's actually, an hour in, we can start coding. So let's go look at the DWM 1001, and I know that I have commit bit on this repo, so let's go look at my PR. What is this branch? This is construct by parts. So let's go also, because like I said, I always need to look it up. Cargo patch syntax. Let's pull up the very handy cargo. Okay, so I have to like look around my mic. This is kind of annoying, but let's move this over here for now. No, that's actually the opposite of what I want. I do want it over here, because I'm going to go look at cargo toml. For now, I'm just going to patch this in. I could just like make it a Git dependency, but this is going to be short-lived, and I would like it to stay short-lived. Crates IO. So this says that I'm replacing a crate that's defined in crates IO. specifically the DBOM 1001. Git is going to be this. That matches there. I think SHA is what they call it, but it's going to be construct by parts. So apologies if the stream's about to get laggy. I think at some point I'm going to switch to using a, I have an external PC. I might start compiling on that or streaming on that or something like that. We'll figure it out, but SHA. No, it's not SHA. It's Rev, isn't it? Cool. So that builds. So now I can also do a cargo doc open, and let's make sure that I have this clicked, because it will open with your most recent browser, and if I clicked somewhere else, then it'll open it in another browser, and that's annoying. Nope, it still did it. Cool. So I have, this doesn't need to be quite so, DWM1000. Cool, I've added these new functions, these functions that are essentially constructors that give me back the peripheral that I want, but they do it in a way that's a little bit more constrained in that, like, it still gives you back the resource, but it gives you, for the DWM1000, like, okay, you need to give me pin 5 and pin 11 on here. And it doesn't even ask you about the RTS and CTS pins because they're not connected on the PCB as far as I know. So I guess this stuff is in there. Yeah. Actually, I think I can get rid of this DWM 1001 local because I also made constructors for the DW reset pin. So we might be able to get rid of this DWM 1001 local module too, which would be nice. So let's look at this, and let's make this a little bit bigger because we don't need everything. So what can I start with? I need a SPIM. So let's go and find the one. Actually, I can just create a DW1000. I have a whole constructor method for this. So let's go find my SPIM, and what I'm going to replace this with is let DW1000 equals DW1000. What did I call? New DW1000. And what do I need to give it? I need to give it a SPIM2. I need to give it pin 16. So I can give it pin 16. I need to give it pin 20 and pin 18. So really, like, all I did in that PR is I took the code that essentially is sitting right here, and I just made a method that says, you know, you're always going to give me this, a chip select pin, and the method just does the degrade into push pull output. Essentially it does everything that you do here. I did keep the, okay, that's right, because the reset is a separate object. So this is going to give me a DW1000 that is uninitialized. So this is this, and then I can get rid of all of this. And then new method, new DW1000 in the root. Where are you? DWM1000. DWM1000. DW1000, excuse me. DWM1000 is going to be up here. No new DW1000 in DW1000. You're full of lies. Are you building the right version? Because yes, this is a function that is just in the DW1000. I put it in essentially the exact same place. Awesome. DW1000, you go here. Let's get rid of dead code. Expected struct common pin found how pin. What? Expected type DU1000. Oh, is the type signature just different? Expected how common file struct. Pin P17. Oh, did I change the type signature of the P0, P17? Okay. Push pull. Pin output push pull. What's going on with this? How does this change? How does this actually materially change the so I've got my pull request here. P17, because I didn't think that I changed. Is it in the return type? Is that what it is? It returns, because I didn't degrade it, but I guess I did. I didn't degrade the, that's what it is. The chip select pin isn't degraded, because here it doesn't need to be because we know exactly what type it is. To be honest, the DW1000, I guess the DW1000 is a generic type, so it does have to know it. This doesn't. How did I get away with this? Does the DW, what does the definition of the, is the DWU file, is that just generic over something that imples something? Where's my struct DW1000? No, I need to actually look at the DW1000. How does the DW1000 define that? Because the DW1000, actually, that's probably what it is. It's generic over something that imples the embedded HAL traits on, that imples the embedded HAL traits. So if I have a DW1000, it's going to take something that imples output pin, and the generic type, they both impl. Okay, so that's fine. This just means that I need to change this because this is no longer just a pin. This is specifically a, exactly what the error told me. It's going to be a P017, which is fine. Which means I'm going to need to get that from the HAL. The HAL is going to have that type here, I think. Oh, P0. I bet you it's going to be in P0, because this is still the older version. This is the, not based on the master branch where we've kind of fixed all of this. Oh, that's fine. That's fine. I can live with that. Cool. So we've switched over. Well, we've switched over that one. Okay, so that's the DW1000. Let's now do that other method that I have called new. It's called new UART or something like that. UART. New USB UART. Okay, so instead of all of this, let's just make this equals, and we're going to need from the DW1000 crate, we're also going to need new USB UART, and we're also going to need the USB UART config, which contains essentially this configuration data. So this is going to be new USB UART, and we need, sorry, I should probably be doing this on my screen. I have a second monitor and I'm looking at this, so you probably have not been following anything that I've been doing. I apologize for that. Let me make sure that I have the docs on the actual screen. So this is like the docs for the new, this is Cargo doc open. So I need a UART, which is going to be device.uart 0. It's going to be pins.p005, pins.p011, and it's going to be config, which is going to be just USB default. I know this implements the default trait, which gives you essentially this. It's 115.200.8N1 is the default. So that's going to be that. So now let's cargo check that. Beautiful. And I know I've got some, I can remove some hardware specific information here now. Pins, I can get rid of all of these. Actually, I think I can get rid of all of this. And yes, okay. Let's go find all of our right calls because I'm tired of this. I'm probably going to get rid of this in a second, but you know, what can you do? I just want to see no warnings. It's such a nice place to be, is in a build with no warnings. Saturday, I think I still need to be here. I think Saturday Derive complains if you... Yeah, that's fine. Okay, no warnings, cool. Now let's get rid of, let's see if we can get rid of that, the IRQ pin stuff, because I need the IRQ pin now. DW reset, so DW RST. Again, I'm doing this on the wrong monitor. You can't see what I'm doing, so it just looks like I'm blindly doing this. Let me close the tab up here so I don't get tempted to do that. So I need to be able to make a new pin with a P024. So, you know what? Let's just get rid of this line and instead use it from, this is part of the DWM 1001 crate. So let's do down here. So we're going to pull this. Let's see if this just works. Because the only problem is the new method wasn't public before. Cool, so I can now get rid of that. Anything that had anything to do with this, and I've gotten rid of the IRQ pin. Actually, do I need this module at all? I don't need this at all anymore. Dead code. Delete. Close without saving. And then let's get rid of that. Local? Is that still here? No. I don't even need the module anymore. Cool. Okay, cool. That's exactly what we wanted to happen. So I think that's... What was the other one? Oh, I set up the I2C, but we haven't used the I2C yet. That's the other constructor method that I did in the PR. But like I said, we haven't used it yet. Let me go take a peek at YouTube to make sure there's no one leaving. I say at the beginning of every stream, I say like, hey, I'm not looking at the chat here, but I have had a couple people make comments there in the past. So let me go make sure it's not that. OBS probably has some smart way of like putting the someone said NTP. Oh, someone in the stream a while back when I was asking what the protocol for getting time over the network is, and it's network time protocol, NTP. So thank you, the person who commented that in the stream. So if you're still watching, thank you. So yes, NTP. Let me put that in my notes while I'm still here. What did I have that? That was an alarm clock. Let's do that so I'm not silly and don't forget. I also am using a new version of Sublime Text, and this is your little Git notifications. I actually really like this instead of the Git gutter. Well, I guess it has the Git gutter too, but setting time. I'm just gonna call this like local NTP, because then I'll remind myself what NTP is and the fact that I need like a local on my sensor node network version of NTP. But it's going to be way simpler. NTP has a lot going on with it. So let's take all of these for now, and let's take all of our new notes. I should get rid of that vendor repo, but git commit switch to branch of DWM 1000 D2M DWM 1001 refactor. Okay, so there's that. So that's refactored. So now I have kind of my minimal parts on this. So now I should probably start refactoring this into a couple of crates. So this logger stuff, right now it's super simple, but eventually it will probably be a little smarter. What do my interfaces look at like this? So I eventually probably could make a no standard compatible logger module. That day is not today, because this is very specific and very ugly, and maybe if I make a much nicer logger. I talked to someone really nice at Embo, who was talking about making a flash logger where instead of having to use a whole file system, it's basically just kind of like a ring buffer for flash medium, where you just kind of keep shoving messages in there, and you kind of have a flash-backed ring buffer. There was a name for it that he had, and I don't remember what it is, unfortunately. But he mentioned that he was going to start looking into that and making that as a crate, which would be really nice. I'd love to see that. So let's step one. Let's make a crate for all of this. This is going to be overkill, but it's going to show me I need at least one external one so I can kind of depend on things. So let's go up a directory. I also need a better initial than Internet of Streams because it's iOS. So I'm going to have iOS logger, and that's going to confuse someone if I ever publish this. So let's just make a crate. We're not going to publish this. Cargo new lib logger. Let's give it a good name. We're just going to call it URD logger. So we're just going to copy all of this. We're going to Control X this code and go over to URD logger. Now UR code. So we are going to need, it's going to need to depend on the NRF52832 HAL. Does the HAL re-export the pack? I can't remember. I think it does. Because then I will just depend on the HAL, which is nice. Re-exports pack. So let's do this, because now it's only relying on one crate. And we're going to need to throw in a big old crunch bang no standard. So this is a no standard library. Yep, we sure don't define any of that. Thanks for letting me know. Sensor node. What version do I use? I use the... Oh, it's like a lock file. HAL is gonna be 070. So URD logger cargo toml 0.7. Oh no, sorry for the lag. You are about to get lag because... Oh no, not yet. We're saved because this is the wrong package name. should I make this a workspace first? No, I'm gonna bite the bullet. Sorry. Well, this is gonna build. So there's gonna be some. Oh, come on. Did I not save? Oh, it helps if you save. Yep. So we're gonna rebuild this. So you probably can't see me because it's probably very laggy because I'm compiling code now. Eventually, I should make this a Cargo Workspace where all of the crates in this workspace share a single target directory. I haven't done that yet because I don't have a good reason why I haven't done that yet. I should just make a I should just make this a Cargo Workspace and be done with it. Okay, let's stop the building. Let's make this a Cargo Workspace. So what I'm going to do up here is the way you make a Cargo Workspace is you put a cargo toml up at the top, and then you go and look at the documentation because you never remember what goes in there. There's something like members. I think members is the only required field. Workspace, field optional, package. What do I do for just a workspace? Workspace members exclude. Okay, so let's go now look at our top level. We have a workspace members equals. For now, we're going to have sensor node. We're going to have URD logger. And I'm going to try and be clever here, and it might mess me up, but let's cp minus r sensor node target to here. What I'm trying to avoid is that when I rebuild this, it's going to go and download everything and build everything from scratch again. But I may end up with very unhappy warnings here. And the other thing I know I need to do is when you have a workspace, profiles aren't respected. Oh, I haven't specified any profiles. But I also need to move sensor node.cargoconfig to here because it now needs to live at the top level because it applies to all packages. So now what happens if I go to sensor node and let's just move target to target backup for right now. Let's do a cheeky cargo build. Patch of the workspace. Oh, interesting. No, you know what? Let's do a cargo clean. I apologize. And then I need to move that patch as we stated. Yeah. So a patch is going to live at the top level. So this is now applied for all of them. So you know what I'm going to do? I'm going to take a minute and go take a break. I'm going to, encoder overloading. Yeah, what are you? Oh no. Oh, it's probably already laggy because my editor has probably gone off for a run. Okay, so you probably can't see anything that's going on, but what I'm going to do is I'm just going to do a cargo build -- all at my top level. This is gonna be bad. Well, yeah, I'll be back in a minute. I'm just gonna let this build and I'm gonna let everything catch up. Oh no, we already had build failures. Okay, so my my CPU load is now down to a more reasonable 6 out of my 4 cores, instead of the 20 that it was hitting while I was doing a cargo release build and trying to stream at the same time. So sorry about that, but now we can pick back up. So we got a clean build, so that's nice. So that's now we've bid the bullet and we've started refactoring parts out. Logger no longer exists now. Close without saving. Sensor node. So now we should actually be able to, from our sensor node, we also need to rely on this. These are going to be the local workspace deps. Dependencies dot UART logger is going to be path equals. I think there might be a way to just say it's in the workspace, but I don't know. So we've got this. Then we're going to go to our, not our librs, let's go to our main rs. And instead of pulling in mod logger, we're going to use UART logger. So now I should be able to do a cargo build all release. And we still build. Great. I need to clean this up. This is a mess over here. Cool. So now we have that. Is there anything else that would be useful to? I'm gonna do the terrible thing, and I'm going to make a cargo new utils. Is this gonna be bad? Am I literally just gonna put delay in there? I'm only gonna put delay in there. So yeah, I'll do it because I'm gonna end up needing to put, let's make utils and let's make protocol in there while we're doing it. And it's complaining because it's not in the workspace, but let's put it in the workspace. Utils and protocol. And then I need to make both of these protocol source librs no standard, and then where's utils? Utils is going to need the same treatment. So how are we going to refactor this out? We are going to perp main.rs. Let's close other tabs. Save. So we can move. Timer is going to need essentially the same treatment that so this is going to be here, and it's going to need some NRF stuff. So let's go to UART logger, toml. It's going to need this same code, or it's going to need the same dependencies because it's going to depend on some NRF specific stuff. It might even require some embedded HAL stuff. So let's do this, and it's not going to work. But where do we pull in timer and timer ext? Timer ext and non-block. I'm definitely going to need. Nope, don't paste. So let's paste this in here. Let's just paste this. Let's take this. And this is going to be way too much, but that's okay. I think I actually can just get rid of this one and this one, this one, this one, this one. And then I'm going to need non-blocking from whatever dependency is here. So copy this line and go to utils, and utils is going to need that. So let's do a cargo build all. Right, it helps if you actually use Rust syntax. Cool, and we need to make this pub because this is that, and we don't need non-blocking error. So now instead of this, also we can remove one tiny 2-line function, but we're going to use utils delay, and then now that I think about it, we need to in this, we need to utils, and then what's the other one we're going to do? We're going to do protocol. We'll get there. I have a feeling for today we're going to kind of I'm probably going to get this refactored out. I might like scratch out some basic stuff. Nah, I'm probably going to be done pretty soon. It's 6:30. I got to go cook dinner at some point. And buffering isn't helping. I think in the future, I think for the next stream, I'm going to try and move my build server in here, and I'll probably end up doing my my coding on my build server. I'll figure that out. So the build server can do the cargo build part, because that'll go quickly, and then that leaves my laptop just to do the webcam and the streaming stuff, which should be nice. It may also be laggy now too, because it's my editor's building, everything's building. So let's move our demo message and stuff like that into some other places. How do I actually make my message? I guess I just use rand. So I guess all of you are going to move here, and I'm going to need probably this is probably what I'm going to need in protocol. So you're this, and then in the sensor node cargo toml, I'm going to need SS Marshall. I'm going to need these 3, and I'm going to need that in this cargo toml. RNG. Oh, we're also going to need. You can see the NRF52 is leaking all over this, but what are you going to do? I might be able to refactor that out later. Protocol. Right, I actually need to pull it in. Thank you very much. You're so useful, Cargo. My poor computer. It's sitting at a system load of 10 on a 4-core processor. It really was not built for live streaming and compiling at the same time. So what can we get rid of here? We can use protocol demo message. And then let's get rid of, we might still need the Serde stuff because we need at least the traits for, or the serialized and deserialized message. So we'll see how much of that is actually needed. But I should be able to get rid of this now, theoretically. Demo message is private, right? And I probably need to make you public. I need to make U public. I need to make U public. My poor computer. So, yep, once we have this building and it's building all the different crates, oh, I'm going to have to update my CI too. Let's do that, and I can kind of talk that out. So really, it's actually not much I have to change. I just have to do a cargo build all in the root crate, and then, you know, it still works. I started looking at the Azure pipelines because they provide kind of a beefier CI environment for open source projects. So I started looking at it. It's a little more complex to set up than Travis CI, but yeah, I might look into it. I don't really need the power that much for this project, but I'd like to evaluate it for other projects that are used in the embedded Rust project, like oh my, field text bytes. Right, and then all the fields need to be public because I did sloppy coding. Okay, so protocol doesn't need serialize and deserialize. I guess that makes sense because it's not doing the serializing and deserialization, which means it probably also doesn't need SS Marshal at all, because it doesn't need to know anything about SS Marshal, because how we serialize is sort of, unless I make a, well, I'll leave that in for right now, because I may end up making that, I may refactor that, where we have like one like message serialized, where we have an overarching enum message type, so you don't have to pull in these in all the places, but yeah, we'll see. For now, it's okay. It's not throwing any errors. Can I get rid of Serde totally now? I can. That's nice. Can I get rid of it in the cargo toml? Well, that's nice. So I still need SS Marshal. Cool. So remove some stuff. That's nice. Let's do a little bit of cleanup. This can be here. This can be here. This is pretty gnarly, this import statement, but I mean, to be fair, it's like we want everything in the crate. And to be honest, in my sensor node, I think I did pull in, I don't need to pull in the pack because I'm getting that from the HAL. And I'm not pulling in the HAL, good. So what happens if I do a cargo build all now? Right, that's why I was doing that. It's because, well, right. Must explicitly pull in for RTFM, so I don't make that mistake again. Because RTFM needs kind of the pack crate to be visible at the top level. So I can at least take this. So let's be a little nicer here. Let's start moving up my, I like using the convention of I put like standard and core dependencies first. And then this is, I've been told that I can also do use as underscore. So then alphabetically, I typically take DW1000 would be the next one. DWM, this beast, would be the next one. D, probably heapless is going to be next. Panic might be next. Protocol, P, no, N is going to go before P. Q R S U. And do you still build? Did I kill anything? I did kill something. How did I? No pack external crate. Right, because it has to be in the TOML. Save. Okay. So these ones are actually kind of special. I might pull out the two special ones. So let's pull out Panic RAM Dump. This is our Panic provider. And then let's pull out this because it let's do this. And I know this doesn't make sense, but let's do this just so it's consistent. And then we've got I'm putzing in my code right now. Okay, so this is fine. And then, oh, the other thing I was going to do is I was going to pull out my, these are the ones that actually come, I want to keep my like crates.io crates and my project crates separate so that it's kind of obvious that these ones are, which ones are which. So these are my like built-in dependencies, crates.io dependencies, and then these are workspace dependencies. Okay, so that makes me feel a little nicer, even if I have, you know, 50 lines of use statements, but what are you going to do? Okay, so now I have the ability to I should probably have like a serialized to string or something like that. That takes, I should just impl the display trait for this, but that I'm going to get rid of this message anyway. So the protocol is going to live in protocol. Okay, this is now building. Cargo build all works. This is going to be messy. 1 through 4, it's going to be like, hey, you deleted everything. Oh no. Oh no. Yeah. Okay. Let's, no, git ignore target. Get rid of that. cd urt logger rmrf./target. That's not a thing anymore. Let's make sure sensor node doesn't have a target anymore. It doesn't. Okay. Let's try this again. Sensor node target backup, right. Okay, this is much more sane. 1 through 10, you look good. Refactor into a workspace. Okay, so why are you giving me a funny icon? Is that because you're a get ignored? Okay, I guess it was ignored, but it was being picked up. Because I probably have it in sensor node. I probably have a. I don't have a get ignore. I don't know. RM sensor node get ignore get add. Let's just clean that up real quick. None of you were cloning that in that exact second, were you? Sorry for causing you merge conflicts if you were. Yeah, you don't exist